G'day folks, welcome to another video, and today we are under pre-security and TryHackMe. We're going to be doing network fundamentals. So I'm going to become a networking nerd in the space of X amount of minutes. Let's get stuck into it. What is networking? What is it? Let's have a look. We've got a bit of a demo from TryHackMe, but we'll do our best to lean on, well, whatever they've given us, whatever resources I can come to mind. But basically, networks allow communications back and forth between people, devices, and all that amazing stuff. What is a key term for devices that are connected together? Well, I think that sums it all up. So I'll type in network, see how I go with that. Cool. It was either going to be network or network. So boom, we got through task one. What is the internet? All right, so networks obviously can encompass local and whatnot. It can encompass all sorts, but the internet is a bunch of networks connected together. So yeah, just devices connected to each other on a bigger landscape. So internet is one giant network, which is absolutely spot on. Yeah, but many mechanisms and methodologies of getting to contact. So AirPanet was initially the first iteration of it. US Defense funded it, invented by Tim Berners-Lee. And yeah, different types of networks, different topologies to orchestrate what a network looks like. And there's also public and private networks. There's many types of things. Who invented the World Wide Web? All right, so we saw Tim there. I'll try Tim Berners-Lee and see how that goes. Hopefully it's right. Yes. I was a bit concerned with the notation there, but we did well. Oh, I've got a viewer side here. To communicate, maintain. Yep. So this is all about device identification and a little bit of communications. We got IP addresses. We got types of IP addresses, so public and private. And MAC addresses. These are hard-coded addresses that sit on a device's network card. And we have IP addresses, which they can be changed. They can also be static as well, but an IP is essentially an address that gives a computer sort of its identification, so that the network knows what's going on. Yeah. So let's go view site, and if it wants to load. To sum up, private and public addresses. Private is generally referring to your internal home network, which sort of sits behind your router, and then a public address is kind of like how you get to google.com. Google.com will have an IP address, which will pretty much be the same, and yeah, your private will have something along the lines of a 192.168 or a 172.1.6 address, or a 10 address. Often the case, 10.0.0.0 dash whatever, whatever it decides to be. Yep, you obviously get an internet service provider, and you got to pay bills. That is definitely the IP of this one. I just made sure that's the case. Yeah, so we have a IP. So here we've got, there's different types of IPs. There's IPv6, IPv4. IPv4 obviously uses 4 octets, and IPv6, I believe, uses 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 octets. So yeah, it's sort of 32 characters there. And there you go. So definitely going to have a bit of more of a read through this, which will give a really good indication. But let's get stuck into it. What does the term IP stand for? So this stands for Internet Protocol. If I can spell, let me see if I did. I got it. What is each section of an IP address called? So that one's called an octet. We can scroll up here, and yeah, octet. Octet 1, 2, 3, and 4. So that makes up 32 bits. Go octet on October. Hopefully I spelled that right. Yep, awesome. We got a win there. How many sections in digits does an IP address have? would imagine if I'm, yep, cool. Just to clarify this, guys, 1, 2, 3, 4 octets. What does the term MAC stand for? So this stands for, this is testing my memory. MAC address, media access control, I think. Media access control. I got it. Awesome. Oh, networking 101. It's sweating bullets here. Cool, got that one. Deploy the interactive lab, use the view site button, and spoof your MAC address to access the site. What is the flag? Okay. So Bob needs to talk. Bob needs to talk out. Spoof the MAC. What are we trying to do here? Doing a spoof your MAC address to access the site. What is the flag? Okay. All right. What have we got here? Vendor who. Okay, so there's that. Spoof the MAC address. Could we just change it to the one that's over there? Let's give that a whirl. Don't like my chances really, but we'll see what happens. We'll make it think it's that. Okay, cool. It's all right. Alice, we need a bit more. I feel like we need a bit more information here. Okay, now we can change it. Yeah, every human is. They certainly do have a unique set of fingerprints. That's for sure. IP address, yeah. Standard. I might need to look at the MAC address section, see where we go from there. Devices will have a physical, which is marked on the board. The MAC address is 12 characters decimal, first 6 characters. However, here we go. We've got a bit of spoofing here. This spoofing occurs when a network device pretends to identify as another device using its MAC address. When this occurs, it will break poorly implemented security designs. So you can do MAC address filtering on routers as a security measure. That means you can say only allow a device that has MAC address X to access X. Okay, places such as cafes, coffee shops alike often use MAC addresses for public, guest and public, free hotel Wi-Fi. Cool, I think it's, yeah, okay. This configuration, yeah. All right, so we have to pay for the service. You'll note the router is not allowing Bob's packets to the TryHackMe website and is placing them in the bin, but Alice's packets, green, are going through fine because she has paid for Wi-Fi. Try changing Bob's MAC address to the same as Alice's to see what happens. I already did that. Oh, no, maybe I don't know if I did. Anyway, let's try it. 0, 0, 1, 2, 3, 2, 2F, 3, 3, 3, 9, 0, 0, 1, 2, 3, 2, 2F, 3, 3, 9, 9. We should be able to get through now. And we have. I 100% swear I made that change and did exactly the same as Alice, because I thought, okay, Alice is getting through. I'll try her MAC address. That was my thinking, but got it correct. Awesome. We've got another little exercise here. So ping, ICMP, Internet Protocol Message Protocol. This is a really good troubleshooting tool and a way to be able to communicate and see if something is responsive. Very good for IT troubleshooting, and is a mechanism to be able to say, hey there, stranger, or lack of strangers, what's going on? So are you there? Are you there? Are you there? And we keep asking the question and we get responses back. So we put out a request, and if they're online and or it's routable or it's the firewall allows for it, it will let you through. And yeah. So all right, what have we got? What are we going to try and do? What protocol does ping use? All right, so that is the protocol, Internet Message Protocol, so ICMP. I'll type it in, just be good. Submit, excellent, whoop whoop. What is the syntax to ping 10, 10, 10, 10? All right, well, I'll just go ping 10, 10. Hopefully I'm answering the right question. Let's see. Cool. Yeah, if you ever want to ping something, ping, then chuck the address in. That makes sense to me. What flag do you get when you ping 8888? So we'll have to go to the view site. This is a network ping, and we want to put in 888. This is Google's DNS. Send ping request. We get a response. We get lots of, yep, and we got the flag. Pinged the server. Done. Whoops. Didn't want to do that. Perfect. So yeah, the 8s are Google's DNS. Alright. Continue your learning intro to LAN. Okay. Sure, do I just go completed? Join intro to LAN room. Let's do that. Yay. Woohoo. Okay, intro to LAN. Let's have a sus. God, I love the topologies. Never had fun remembering these. Star, bus, ring, and switches, routers. These are pretty old school, I must say, but somewhat relevant. A switch is kind of like a ability for, I suppose, the devices to all connect via the switch. And essentially, a switch will be in the same sort of network and all feed through the router. However, a router will connect via different networks, essentially. So, example, internet. Switches don't usually, and these days, that switches and routers are kind of all in one. Back in the day, though, and still, there are the cases of where you have dedicated switches, which are primarily around having network ports, so that devices can, connect to specific resources based on what the switch is connected to, which is usually, obviously, in this case, a router. The router, obviously, routes the traffic through the internet, and they just all talk. They all talk. Let's have a look. So, job of router is just to pass data between computing devices from the switch and vice versa. Okay, what does LAN stand for? Let's go. Local area network, off the top of my head, and I'm sure it's up here somewhere as well. Submit. What is the verb given to the jobs that routers perform? I would say route. That would be my guess, but I could be wrong. Pass data. Yeah, I'll try route. Nope. What is the verb given to the job that routers perform? It's a router's job to connect networks and pass data between them. Routing. Silly me. That was difficult. A real struggle there. What device is used to centrally connect multiple devices on the local network and transmit data between them? So this will be switch. It's going to be switch or switches. Yep, switch. What topology is cost effective to set up? None of them. So we just go, we can even just do a control F for cost effective. No, it's not going to go. Despite the cost, more cost effective. So we'll try a bus. Might give us a bus topology. Topology, and I reckon we've got a winner there. Yep, happy days. What topology is expensive to set up and maintain? So if we just do a control F for expensive, star topology gives us the result. Star topology, can't spell. Boom, whoop whoop. Complete the interactive lab. What is the flag given at the end? This lab will take you through. Hopefully this is. Imagine this is the right one. Yep. All right, in ring topology, all devices are connected to two others to create a full circle. Packets of data travel from one device to the next until they reach their destination. One of the major flaws with the ring topology is that if a device goes down or a cable is broken, then no data will no longer be passed. If you're in the middle of the network cable, you can cut it and see what happens to the packets. Yeah, I don't think it's don't think it's going to go well, mates. Cool. Stop the connection there. Packets can no longer travel around, so that's nice. With bus topology, all devices are connected to a single cable, often called the backbone. It's sent in left and right directions for the packet to reach its destination. Major flaw in this topology is that it can't handle a large amount of data. On the next step, just try send as many packets as possible. Alright, this is going to test out my networking skills. I'm going to go computer 1 to computer 3. Let's give that a go. Send packet. I'm going to take this network down. Interesting. This is going to test my knowledge. Where can we go? Can I just do this? Hey, there we go. Just had to absolutely go to town there with the start topology. All devices are connected with their own cable to the central switcher hub. Every packet is sent through via the switch, which means the switch goes down. No longer. This is more common. See if you can somehow break the switch. If I just cut it. So I've got to get the switch to go down, but it's connected to everything. Just remove the switch. The network is now down. And we got a flag. Topology flaws. Sweet. All right, what have we got here? Oh, subnetting. Screw subnetting, man, honestly. Yeah. No, I don't know. I just don't like subnetting. It's always been my Achilles heel. I'm going to struggle here, boys, ladies and gentlemen. What is the technical term for dividing it? Yeah, subnetting. How many bits are in a subnet mask? 32, I believe. Yeah, awesome. Just to clarify, so there's 4 octets, and they all marry up to 8 each. So 4 bytes. Yeah, I forget how it all works. It's going back to networking 101 days. What is the range of a section octet of a subnet mask? What is the range of a section octet subnet mask? Depends, I think. Or is it just this? Nope. What is the range of a section? I've got to find my subnet mask here. Let's have a look. Network address, host address, default gateway. Company exactly. Cafe 2 network, subnetting. Yeah. What is the range of it? Is it this? Oh, cool. Fair enough. Okay. What address is used to identify the start of a network? It would be, I know there's a broadcast address at the end, and there is a broadcast I feel like is near the end or the end. Network address. I don't think that'll be it, but we'll try. Okay, cool. What address is used to identify devices within a network? I thought that was too simple. What address is used to identify devices within a network? Would be host address, I guess, based off that. Sweet. Kicking goals. What is the name used to identify the device responsible for sending data to another network? Ooh, we got a bit going on here. Default gateway. Sweet. As per that one. Cool. We're making some progress, ladies and gentlemen. How does ARP work? ARP table. Yeah. What does ARP stand for? Address something protocol. I didn't really look. Address something. Resolution protocol. Never been able to remember that one. Protocol. Boom. Whoop whoop. What category of ARP packet asks for a device whether or not it has a specific IP address? This is going to test me. I'm not an ARP expert by any means. I'll try a request, see what happens. Cool. Got it. Done it. What address is used as a physical identifier on the network? So we've got MAC address. Oh, cool. It liked that one. What address is used as a logical identifier? So that's an IP address. It got me as close enough and good enough. The DHCP protocol. Dynamic host configuration protocol. I imagine it's going to be on the question. What type of DHCP packet is used by a device to retrieve an IP address? I'd say Discover. DHCP Discover. Give that a go. Well, got that one. What type of DHCP packet does the device send once it's offered an IP address by, let's say, be acknowledgement or DHCP offer? Looks to be the next bit in the chain. Maybe not. DHCP when a device has not already been released on an IP address, it sends out a request DHCP Discover to see if any DHCP servers are on the network. It sends back a reply, and the device then goes. And then lastly, the DHCP server sends reply acknowledging it's been completed. What have we got? What type of DHCP packet does it send off once it has been offered an IP address? DHCP request? I don't know if I just did that. Makes sense to me. DHCP ARC. Look at us kicking goals. All right, OSI model coming up. Completed. Yay! Share it on the LinkedIn. Sounds great. Okay, so they've sucked me in. They've paid up the big bucks. Get a bit of a subscription going. All right, OSI model. This is also. I remember there was like some kind of pizza acronym, but anyway, something standards got it completely wrong. Open systems interconnection model. Open systems interconnection. Cool, I spelt it right. How many layers? 7. What is the key term for when pieces of information get added into data? I'm going to say metadata. No. What have we got? How many characters are we after? Oh, jeez. What is the key term for when pieces of information get added to data? I feel like it's something, different functions. Specific feature, encapsulation. There we go. Boom. All right. Layer 7. What is the name of this layer? Don't know off the top of my head. Sounds like might be application. Thank you. That's good. What is the technical term that is given to the name of the software layer interacts with? Be the browser, I'd imagine. What is the technical term? Is it graphical user interface? Looks like it to me. Makes most sense to me. Yep, done. Presentation layer. This is a little bit of protocol stuff. What is the name of this layer? Well, just told me at the top, presentation layer. And it is, might be standardization. It's the only buzzword I can find here. Makes sense to me too. Let's see. Did I spell it wrong? Space. Okay, fair enough. Maybe presentation again. This is a translator. I'll give that a try. I'll spell that right. Sweet, done. Layer session. What is the name of this layer? We've got that one up the top. Session. What is the technical term for when a connection is successfully established? I would say that would be something good. The technical term. Once the checks in place, divide small chunks, this dividing up beneficial, the connection is lost. Session layer. Session makes sense to me. Cool. Technical term for small chunks of data. Bits or bytes, I think. Packets. Packets, yep. Done. Transport layer. Oof. It's a big boy. Oof. Transport. Hopefully I got that one right. What is TCP? Transmission Control Protocol, I believe. Protocol. Sweet, got that one. Something datagram protocol. Universal datagram protocol? Might be something like that. Universal. No, I doubt it'll be that. UDP. User datagram protocol. Close. Close. User datagram protocol. What? User datagram. My bad. I failed. Should be good there. What protocol guarantees delivery of accessible data? That's TCP. What doesn't care? Definitely UDP. If I can spell. What protocol would an application such as an email client be using? SMTP. Simple mail transfer protocol. POP3 maybe. Nope. Probably UDP. Is that what we want? Okay, we'll try TCP then. Fair enough. The more you know, what protocol would an application that downloads files uses? UDP, I'd imagine. Seriously, is every answer? This is definitely UDP. Finally. Cool. Up to the network layer. This will be called network. Will packets take the most optimal route across the network? They'll try. Cool. What does the acronym OSPF stand for? Open something. Open shortest path first. There we go. Open shortest path first. What does the acronym RIP stand for? Something internet protocol. Routing information protocol. Been a long time since I've done my Cisco. Clearly. What type of addresses are dealt with at this layer? IP addresses. Layer 3, yep, definitely. Boom! Alright, data link. What is the name of this layer? Data link. What is the name of the piece of hardware that all network devices come with? What is the name of a piece of hardware that all network devices? Network interface card. Sounds about right. Cool. Done. Physical. Yep, the actual cabling. We call this physical. What is the name? The name of the numbering system of both it's zeros and ones. So it's binary. What is the name of the cables that are used to connect the devices? Ethernet cable, maybe. Cool. Also known as RJ45. Practical OSI game. Can you escape the OSI dungeon? Climb levels in order to escape the dungeon to reveal the flag. Can you beat our highest staff score in 19 seconds? Probably not, buddy, but let's give it a go. Our hacker has been locked in the dungeon. Their only chance of freedom is by choosing the correct path based on the OSI models. Please move your cursor keys to left or right to enter the doors. Physical. Oh. I have to press space. Data link. Network. I'm just going to move that out of the way. Transport's next. Session is next, I believe. And presentation and application. Yay, I did it. Only took me 64 seconds. I reckon I could do that a bit quicker next time around. Submit. Done. Alright, let's go to packets and frames. Not my most favorite topic of all time, but we'll have a look. I'm going to join this room, do I? What is the name of the piece for a piece of data when it does have IP addressing information? Yes, I'll join this room. Okay. What's happening here? Cool. Thought I was already there. That's fine. Thanks. What is the name of the piece of data when it does have IP addressing information? Let's suss it. Frame, maybe? Nope. Is this frame? Cool. Good to know. Packets. Packet. Cool. Done. TCP IP three-way handshakes. There's a bit of FIN-ACK. What is the header in a TCP packet that ensures the integrity of data? Looks like a FIN seems to be the one there. Okay. What is it? What is the header of the TCP that means it's good? Maybe ACK? SYN? Might be SYN ACK? ACL? Checksum, of course. Ugh, silly me. Provide the order of a normal three-way handshake. So it'd be SYN ACK, SYN ACK. Done. Practical handshake. All right, let's have a look at this one. Cool chat. Are they going to talk or? What is the value of the flag being given at the end of the conversation? Just don't know if they're conversing, to be honest. Can you just do something, please? Enter the value of the flag. Thank you. Okay, SYN, can you hear me, Bob? Yes, I can hear you. Okay, great. Yes, I can hear. What is going on here? I think data. I hear. Okay. SYN receive. Yeah, me too. Cool. That was a bit kerfuffle. I got a bit lost there, but got the job done. UDP. All right. Get out of there. Thank you. What is... I should know this. User datagram protocol. Sweet. What type of connection is UDP? Connectionless. Oh, no, it's best effort. Unstable? Is that long enough? No. It's definitely connectionless. Stateless. There we go. That's the keyword we're after. What protocol would you use to transfer a file? FTP, file transfer protocol. It would be TCP. Yep. What protocol would you use to have a video call? That's UDP. It's best effort. Ports. Yes, we have a lot of ports. There's a few key ports there. Alright, bit of a flag here. Let's have a squizzy Rooney. Alright, what are we doing? Typing in 888 on port 1234. Connect. And that is connecting to a port. Woohoo! NC, I'm just trying to see. Cool. Alright. Final room. Extending the network. Terminate the static. Yeah, done. Thanks. Alright, let's have a look at the final one. Yay, everyone's happy. If you could just take me to extending to your network, that'd be great. Okay, networking, extending your network. What is the name of the... Yeah, I'm already here, bro. Don't do this to me again. What is the name of the device that is used to configure port forwarding? That would be switch, I believe. Layer 2, port forwarding, router, actually. Yeah, router, my bad. My bad. That would definitely be a router. Firewall. So this is definitely really helpful to help stop bad stuff from coming in and allowing good stuff through. What layer? Oh, is there multiple? Is there? Okay. What layers of the... there's definitely a few that operates that, I would have thought. Stateful, stateless. Trying to think. Not really physical, hardware wise might be... I'm gonna have to... Yeah, firewall. Firewall's definitely not my strong suit. So it looks like stateful for this one. Stateless, I would assume. Yep. So 2 layers. Imagine it'd be the layer 2 level, layer 3. I'll try that. Maybe layer 3, layer 5. Thank you. That clears that up. Network and transport, I believe. Yeah. All right, let's have a look. We've got a flag. The website 203 is under attack. Quickly change the firewall settings to stop this server from crashing. Packets are in reds from the attacker's machine. All right, so that over IP there is under attack. Quickly add some file. Yeah. Alright, so the bad traffic is coming from that address, and the destination IP is that. What type of packets? Did it say web traffic? I can't remember. Ah, yeah, piece of shit. All right, that one. Let's drop that. Let's just drop that. I'm just gonna add all of them in. Hey, you can't get through now. There we go. You saved the server. I did it. Just add every rule ever. Cool. That one's done. VPN. All right. Virtual private networks. Hey, here we go. VPN obviously allows to communicate securely by a dedicated path. Goes through a tunnel. What VPN technology only encrypts and provides authentication of data? IPsec, I guess. Or is that the bottom one? I think that's the bottom one. PPP. Sweet. Next one, we have LAN networking devices, switches and routers again. What is a verb for the action a router does? Routing. I think we did this, cover this earlier. What are the two different layers of switches? Well, we've got layer 2 and no, layer 2, layer 3. Excuse me. What are two different layers of switches? Pretty sure that's what I put in. Right, yep, fair enough. A little technical trick, hey, you gotta love that. Deploy a static site attached to this task and experiment with the network simulator. The simulator will break down every step of the packet, sending a TCP packet from computer 1 to computer 3 to reveal the flag. Oh, let's see how we go here. Alright, we want computer 1 to computer 3. So we want computer 1 to computer 3. What type of response do we want? TCP packet. Okay. Let's go test. Bit of back and forth here. Who has computer 3? Tell the router. Hey router, I'm computer 3. Computer 3 received a SYN packet from acknowledgement to computer 1. SYN packet to computer 3. There's a lot of communications going on here. Think of deploy the static. Ah, cool. I did it. The communications were good. Okay, so I've got that. How many handshake entries were there in the network log? So we'll just do a count 1, 2, 3, 4, 5. Boom! Hey, here we go. So look at me go, guys. I hope you're enjoying this. Definitely feel like I'm kicking goals and doing basic stuff well. Yeah, what have we got? What have we got? So we have finished off in network fundamentals. Obviously, next will be how the web works. That will be next on the agenda. So, guys, I hope you enjoyed the journey. And yeah, if you enjoyed the video, click like, subscribe away, all that good stuff. Thanks for kicking around and sticking around. I'll see you in the next video.